I'm here with Jonathan Frankle.
Yep.
Did I say your last name right?
Oh, you got it.
Okay, you're the Chief AI Officer at Databricks.
Chief AI Scientist.
Okay, Chief AI. Say okay.
Yeah,
let's double take.
Don't give me this officer stuff. I'm not that important.
Okay. So there's a lot of talk about context and context for AI, not just at Databricks, but I think that's just like the industry trend right now. Can you actually help explain what that actually looks like with AI?
Yeah, it's complicated. I mean, let's take a really simple example. Genie Spaces at Databricks. Really simple looking product on the surface. You want to ask a question, have it translated into SQL. AI runs a query on the SQL table and gives you back a natural language answer. For mere mortals like me who don't speak SQL, and I do not speak SQL, at least not the kind of SQL that needs to be written to answer my questions, this is an awesome product. Context there. So the first bit of context is a SQL table, right? Like that's got the data. But nobody documents a SQL table. Nobody knows what these values mean, where they come from, what these column names mean, the context. You bring in many SQL tables, how do they relate to each other? Okay, so now you need even more context. There's a human layer of context that needs to be provided. You got to describe what this stuff is. Okay, more context that was implicit. You have to figure that out, discover it, write it. And then you get into questions of memory. Like, let's suppose I ask a question and the LLM does a lot of work to explore the data, understand what's going on there, and then answers my question. I should not come back and ask the same question tomorrow and have the LLM go in, learn about the data for the first time again, go in as if it's just started from scratch and do this again. So memory shows up. Let's suppose I mention something in this query that is not written in the data and is not provided in the Genie context. Does that get remembered for me personally so that I don't have to explain this again? That's information that's not represented anywhere. That's context. Context, and that's just one SQL table. Now let's take a Databricks workspace. You have 10,000 SQL tables. A lot of them are bronze versions of gold tables somewhere else, perhaps not labeled as such. A lot of them are potentially duplicates or views of tables that are out of date. You've got dashboards. Some dashboards are definitive and people are looking at them all the time, and some somebody created one-off and are wrong. You've got a bunch of unstructured data. You've got notebooks. And the big version of Genie Spaces, which we call Genie 1, you just ask a question about your Databricks data, all of this context, and ask something really simple. Like I love to ask things like, who the hell is using all the GPUs right now on my team? And what are they doing with it?
I was going to say, why?
Yeah, why? And it's, we have some tables that keep track of all the jobs on our GPU cluster for us internally and have all the logs. So it is possible using AI query to figure out what are people doing with this and actually make sense of all that information. It's really exciting using AI functions. But I don't know how to write that SQL query. I'm a human being. I'm not Mate. I'm mortal. And so I have to figure out, I have to ask Genie 1 how to do this. And Genie 1 has to answer that question. And it doesn't just have access to that one table. It has access to the entire internal workspace for my team or for many teams at Databricks with tens of thousands of SQL tables and all sorts of other crap floating around, some of which is important, some of which isn't. That's context. That's really freaking hard. We look at these toy examples of just working within a code base, which is hard enough. But this is working within something, this is working within all the data at a company. How the hell do you do that? It's a really hard problem. And I think it goes beyond really anything anyone's tackling right now in the field. It's presented huge challenges for us. We've worked our asses off to make this happen. And it's keeping us busy. And it's a problem that I think, my friends at a lot of the foundation model labs are envious of, honestly, because it's really hard.
Semi-politically correct way of asking this. So when I look back 2.5, 3 years ago, though, we were basically told by the industry, just throw LLMs at the problem. And now we're back to that. Oh, you got to curate all these things.
Oh, who was telling you just throw LLM at the problem? The industry.
Yeah, exactly.
The man.
Yes.
The man wants you to just use the big LLM. No, I think what we've learned is that intelligence without context and structure and purpose doesn't really accomplish very much. And you can point to a lot of things for this. Like I spend a lot of time talking about evals for LLMs. The reason I talk about this is because you can't just take the world's smartest LLM or the world's smartest person and point it at some information and say, go do work. You have to explain what the job is, and you have to know whether the job was done well. That's true with humans. That's true with interns. Sorry, interns are still humans. Sorry to all my interns. It's true with LLMs. It was true with expert systems way back in the 80s. What does good look like? And how do you know if you've got something good? Specification, describing what you want the AI to do. That's a key part of this that's missing. That's something we have to work on. That doesn't come for free just because you have a really smart model. Context is similar. You take a really smart model and you don't give it access to enough information for it to actually answer the question. It may or may not still give you an answer. But if you didn't give it the right information and you didn't check the sources carefully, it may not be a good answer. And now this context is huge. And LLMs can traverse huge context. We've had a bunch of cool results on that this spring. It can be slow as hell if you have to have the LLM newly figure out what to do. Yeah, it gets expensive.
Yeah,
This stuff is pricey these days. A lot of customers talk about cost. And if you just merely throw an LLM at Databricks, at a giant Databricks workspace, first of all, you're not going to get great answers because it doesn't know a lot about Databricks or know a lot about your data. If you throw Genie at this, we've worked really hard to fix that. Like we put a lot of effort into Genie code and Genie 1 specifically for this. But also, it's just a huge amount of information. You give a human 1,000 years to look through all this stuff, they're still going to have a hard time making sense of everything that's there. It's remarkable that Genie 1 works in some sense. We should just be astounded. 5 years ago, this would have been like unimaginable. But that doesn't mean you just get it for free by throwing the LLM at it. There's been huge amounts of product work, engineering work, and research work put in to make all these Genie products feel like they're easy and feel like you're just pointing an LLM at a Databricks workspace.
So touching on the note of like looking back 5 years ago, I had a conversation with Matei touching on the whole determinism versus probabilistic. I find it interesting how for so many years from a data engineering perspective, which my background is more on the analytics and data engineering, we spend so much time making sure everything matched to the last decimal. Then LLMs come in and we're going to probabilistic. Oh, it's okay if we're wrong 5% of the time. It's okay. Obviously, there's a cost trade-off that you have to factor in, right? But now we're going back to more of those deterministic moves, which I would say like the semantic modeling, ontology, all that stuff helps move toward that. That's a long-winded thing to say that it is interesting how even it was announced the Genie ML, which we're going back to a deterministic approach.
Yeah, I think the answer is that the world is complicated, and we need to like accept that we live in this in between. You have your wildly probabilistic world of just like throw the LLM at it and whatever it says, roll with it. It's good enough. Like. You use Claude Code or Codex, don't even look at the code, just, it wrote it, it's probably fine. And the determinism of like, inspect every line of code and code review everything and sweat every detail. And the answer is, most of the time we need to be in between. The world is probabilistic. The world is uncertain. Humans are probabilistic. Humans are mushy and uncertain. Data is wrong. Data has fundamental issues that you can't always fix perfectly to the last decimal. And so let's just accept all of that and measure very carefully whether we're getting good enough quality on our task. And what good enough means varies from context to context. If you're doing a healthcare-related application, obviously there's a very high quality bar. If you're doing, a chatbot about sports, it still has to be good, it still has to be safe, it still has to be pleasant to work with, but it's okay if it's wrong sometimes, and that's deployable. So it's really, I think we're just accepting that the world has nuance. And that's, as computer scientists, we like zeros and ones.
Well, but what I do find interesting about it though is honestly is the fact that now we're using probabilistic models to create those deterministic models, which I think is the right move. By the way, I'm not arguing it's a bad move.
I actually love this.
Yeah,
like one of the things I've been trying with Claude Code in my home projects is like, how do I use AI to build the kinds of like just deterministic code-based systems that no human would ever bother to build because it's so intricate and such a pain in the neck. But I can just now use AI to do that. But it's kind of the metaphor I use, and this is just a personal thing that I'm experimenting with, I won't claim this is a Databricks framework, is like AI in the control plane, code in the data plane. in some sense. Which is like, that's one possible model of the future. There are a lot of different models of the future, but it's also better for my token budget on my personal credit card to do it that way. But I've built some really cool stuff at home where I'm just like, oh yeah, this is all fully deterministic, like fully, like I'm not going to have the AI weirdly accidentally, send my credit card number to who knows where. But I'm using AI in a way where no human could have done this. This would never have been worth my time, not in a million years.
Yeah, I mean, my personal philosophy on this is you use AI to build deterministic tools. So, which is you can see basically your approach.
But I feel like that's still limiting. And it's like, that's one, imagine we're 30 years from now and there's some very well-worn design practices for how to build systems out of AI. In the same way that, like, in software engineering, we have object-oriented programming and design patterns, and like, we test things before we ship them, and all sorts of other basic practices, structured programming that didn't exist in the 60s. And if we're in the 1960s right now of AI in some sense, and we've got 30 more years to go until we have clear best practices where, like, in software, there are certain thoughts that we are not physically able to think because they've been written out of the language and written out of the books. You can't put a go-to statement that jumps somewhere random in a Java program or a Python program. That does not exist in our vocabulary. And that will happen in AI at some point, where we have some design patterns that we really like. We commit ourselves to restricting our expressive ability to make sure that we actually build reliable systems. And one possible pattern could be exactly what you've described, like deterministic, but complex and built by AI. There are all sorts of other patterns you could imagine. I don't even know what those are yet. If you read in the 1960s, they all knew that the practices were bad. And you can read some of what they said things might look like, and it looks stupid as hell compared to what we got. We got some really brilliant stuff and a bunch of Turing Awards given out for some of these key ideas. Those ideas did not exist in the 60s. And so you and I can sit here and talk about where we think this is going, and we're both gonna, thankfully this is recorded on video,
yes,
not just written in some, little PDF 2-page paper from the 60s, and everybody can laugh at us. If the year is, 2050 right now, please laugh at us for all these silly development practices we're talking about and how stupid we look. Because we all have a lot to learn. I think it's just, in general, I like to remind our customers and remind people internally, this is powerful technology. It's deeply flawed right now, and we haven't learned how to harness it yet. And we need to be humble and respectful of both the power and the risk, and recognize that we're at a very early stage of this.
So with that said, it is flawed, but there is value in different ways. Where do you see the value today? It's your business. You're not a chief AI scientist. You are a CEO that is responsible for a budget that goes beyond tokens and staffing. I say that in the most respectful ways.
Yeah. Where's the value?
Where do you trust these systems today?
So I'll tell you where I trust them today personally.
Yeah.
Like where I'm getting a lot of value day to day with me and my team. The first is just asking questions. There's so many basic questions about how something works at Databricks. We're a big company. I don't have all of Databricks in my head. How does this work? Who do I talk to? What is the documentation for this? Give me a summary of what's happening here. I'm meeting with this customer. Who are they and how's it going? And like, what are similar customers doing? And like, what products are they using? Which products are they not using? And where did they get stuck a few months ago? And how are they doing on that? Like, brief me. Who's using all the GPUs and why is it always the interns? Like those kinds of questions that historically would have required actually a lot of effort to answer. I would have had to disturb 5 other people, wait a day or two, write a query myself, write a dashboard myself, something that I would have probably done badly and messed up.
I was gonna say, you don't like SQL, so...
No, I'm really bad at this. I'm human, and my focus is on doing science, and I don't have time to keep track of complex SQL queries in my brain, and I don't want to trouble one of our data scientists over my silly query. Like, they have much more important things to do for the business. They're really expert at what they do, and I'm grateful we have them. This is not worth their time. But now I can just ask a question and get an answer. And there's so much in enterprises that is just communication latency and communication bottleneck. Who's the right person to talk to about this? Oh, let me ask this person about this. Oh, they know this part of the answer to the question, but I need to talk to that other person. And if I get them all in a room, let's have a meeting. We'll schedule it for next week, and we'll all talk about this. And finally, I'll get the answer to my question. I eliminate all that latency, and I didn't disrupt a bunch of other people at the company. And that's monumentally valuable. That is Genie 1. Like, that's the whole point. And Genie Code as well, if I want to actually build stuff. But like, just the idea that I don't have to disturb 5 people when they hear like, oh, the chief AI scientist has a question for me about this thing. Let me disrupt this other, probably much more important thing they're working on. No more. And the other for me is actually, I can expect a lot more from my researchers And not in the sense of like, oh, they need to do 10x as much work, but in the sense that like for like doing science is really hard as it is. Like just getting a number and saying like this worked better than that, and we feel confident about this is really hard to do. And during my PhD, during the early years of Mosaic, that was hard enough. Actually showing the value in a way that you can understand, building a demo, building a dashboard, making something we can vibe code, connecting it to real data, showing a product prototype. It's like, okay, hand it off to the PM, hand it off to the engineer, let's bring in the engineering team. Now, I expect every single person on my team, if they say, I have a result, not only should it be a graph that doesn't look like shit, because now, Claude is very good at matplotlib, but also there should be a demo. Don't just do a piece of science, think end to end and show off what this could look like as a product in some preliminary form, and hand that to me and a PM, hand that to an engineering team. So I can just expect people to think bigger and have fully formed ideas in a way that was just physically impossible before. And for me personally, that's been life-changing. We're using Databricks Apps a lot for this, quite frankly, because it just allows you to basically spin up new Databricks product surface that didn't exist before and show what it could be. And if nobody likes it, you invested 2 hours in this. Throw it away. It's not heartbreak of like, I spent weeks on this and the boss didn't like it. It's like, oh, I spent 2 hours on this and the boss didn't like it. Cool, I'll throw it away and maybe I'll try again.
Oh, it reminds me of when I did an interview with Ali. One of the things he basically said, like, hey, in the future is everything is going to be an app, everything.
Yeah.
So
because we can create any product surface we want. For my team, it's been incredible that like instead of showing up to our engineering teams with a cool number on a plot where we say, and then we have to explain, here's how this might be valuable to you. We don't just show up with like a prototype product. We show up with a prototype product that we tried with a customer already. And we show up with the complete package to a product team saying like, here it is in a silver platter. This idea that we took end to end, we tried it with the customer, we showed how interesting it is. What do you think? And sometimes they say, that sounds really cool. And sometimes they say, we've got more important stuff. But the idea that like it has smoothed our communication between research and engineering and product and customer, because we can all speak the language of an artifact everybody can touch. There's no explaining, there's no saying, well, what if we had something like this? Here, look at this thing on a whiteboard. It's like, go try it and see if the experience feels magical to you. See if this is good for your use case. And if it isn't, give me that feedback and we'll go try again. It wasn't that hard to build this interface in the first place.
Whereas before you would be crush and cry in a corner.
I mean, basically, yeah.
Yeah. It's like, oh, shit, I just spent one month working on this and my boss just said, no, it's not a good idea.
Yeah, it's allowing us all to like, your imagination no longer stays in your head. And that was what drew me to computer science in the first place. Like when I was in college, I wanted to be like a mechanical engineer. Then I realized like, oh, there's a lot before you can even build a thing. Like you can't just build a car on your own. It's a lot of people and a lot of effort and a lot of communication and a lot of money. And with code, you can just sit down and create the equivalent of a car or a spaceship or anything else just using your imagination and bringing that to life. And I feel like now as a scientist, I feel that way about bringing products to life. And that's just, I don't know, it's really cool. This is kind of the full realization of what brought me to computer science in the first place.
On one hand, there's always the new model claiming to be the fastest, the best, and all that stuff. Always in everything but one category. But I've also heard from some folks that think that at the end of the day, there's a lot of optimizing for benchmarks and not optimizing for real world outcomes. So love to hear your take on this potentially very nerdy but controversial topic.
Oh, see, I think this is actually really simple. We at Databricks have the real benchmark, like the one true benchmark of whether AI is good. It's called our customers. And there is nothing like going and trying it out on a real use case and chatting with the people who live or die by whether this next model release is better, faster, cheaper, and asking, what do you think? And that is honestly the greatest luxury and joy of being here, if I may say so. Like there are a lot of great things about being at Databricks, but for me as a scientist, the idea that there is no boundary between research and customer, that, I'm not at a big lab where I'm a researcher and that means I have to go talk to the engineer who talks to the PM, who talks to the salesperson, who talks to the solutions architect, who talks to the customer, and then it has to work its way back to me. And so I can, kind of ignore the customer. As a scientist, I am not doing my job properly unless I'm spending a lot of time with our customers and trying out our technology in their hands and asking them what they think. Benchmarks are proxies for that because I don't want to bother the customer all the time. We have a lot of our own in-house benchmarks, and we're always adding new ones. And we look at the academic stuff as well and the open source stuff as well. But again, there's complications involved in that. But the one true benchmark is, did someone find it useful? Did it make a difference in their business? And
how was your experience today? Your shopping experience today?
Honestly, it's like I can call up my friends at a bunch of different customers who I've gotten to know over the years here, and I can ask, like, what do you think of whatever 4.8 or whatever 3.5 or whatever 5.6? Like, is it good? Like, what is your take? How's it doing on your task? What are you vibe tested this a little bit on your use case. You're considering A/B testing this. Like, what do you think? That is the one true eval. That's the problem we're all trying to solve. AI that's useful in the world. And it's really cool to feel like, all of us across the industry, we all have that eval. But I feel really lucky that at Databricks, as a researcher, I actually get to look at that eval. I'm not insulated from it. It's not 5 layers away. Like, I get to go end to end, and the people on my team get to go end to end. And I think it makes for a special experience for our customers as well. And I think that's part of why our products are so awesome. Like, everybody's customer obsessed, down to the RL researcher who, you would never expect to talk to a customer. They're the one who asked this week, can I come with you and talk to a customer because I really want to hear more about what they're doing? That's special.
Awesome. Well, thank you so very much for your time, man.
Yeah. Thank you. This is great.
Thank
I
you.
really appreciate it. Glad we finally got to do this.
My pleasure, man.
Yep.